Hey Daniel, fancy meeting you here at Home Depot.
No way, Jakey, what are you doing here?
Just running some errands. What about you?
Oh, funny story. My parents just bought me this brand new dog, Megan, and they want me to build a kennel for her. Here's the thing. It has to be rectangular, and I only have 330 feet worth of fence. What can I do to build this?
Well, I'm not really sure. I'm pretty sure Miss Strader made a video for Algebra 2 on how
Did
to
she?
build this.
Oh my god, let's check it out.
Let's do it.
So, Miss Adams, Miss Marcus, I have been thinking about getting a house.
Oh, that's exciting.
Yeah, and I really wanted to have a garden in the backyard.
Oh, very pretty.
I love flowers. So I want to make it simple though. So I'm thinking about just doing a rectangle. And I went to Home Depot this weekend and I bought 330 feet of fence. It's just like what it came in. So I really want to make this garden as big as possible. I might as well get the most for my money. So I was thinking about putting it, I don't know, like somewhere around here in my yard.
Okay, that looks nice.
But I was trying to figure out what the length of the rectangle should be to get the maximum area for my rectangle. So what do you think? Like, what do you think I should use for lengths?
Well, I mean, why don't we just take some sort of guess and like see what we get? Let's just pick a number and see.
Okay.
So
Let's do that. What do you want to try?
I would like to try a side of 100 and see where that gets us.
Okay.
So let's say that this is going to be like a zoomed in version of your garden here. So let's just say that this side is 100 feet. And since it's rectangle, that means that this side's going to be
Right.
100 feet.
Okay.
Okay. And you said that you had how much total?
330.
Okay. So if I've already used 200, then what I have left over is 130.
Mm-hmm.
And I need to split that amongst the other two sides, right? So that's going to be that
Right.
this one is going to be 65. And this one's 65.
Okay.
So then let's see, what does that give us for area?
So 65 times 100
Yeah,
is 6,500.
right. So it's going to give it 6,500 square feet for your garden.
That sounds like a lot.
That does sound like a lot.
Let me try one and see what I get.
Okay.
So I'll try 75.
Okay.
So here's my rectangle. And I'll try 75 for these two. And then that makes up 150.
Mm-hmm.
Can you help me out here?
Yeah, so 330 minus 150, 180.
Got it. Okay.
Right.
So if I split that, that would make each of these sides 90 feet.
Right.
Okay. So my area would be 90 times 75.
And that gives us 6,750.
Okay, so mine's actually bigger.
That's more.
Okay.
Interesting.
I really don't feel like sitting here and trying every possible rectangle.
I mean, I feel like that could take us a long time.
Yeah.
Hey guys, I have a different idea. I'd like to maybe save some fencing, and what if we made the garden against the side of the house like this? We could just have 3 sides that need fencing, and then the 4th side is just kind of barricaded in by the house. And I feel like that way, since we only have 3 sides, maybe we can get a little more area out of that. I don't know.
That's actually not a bad idea.
So let's see. Maybe I'll just try some numbers to figure out how this is going to work. What if I made like 100 feet on the left and the right hand side, and then the left hand side would also have to be 100. And then let's see. We have 330. I've used 100 plus 100. I've used 200. So there'd be 130 left over. And I'm really glad that that actually will fit, because I know that there's only 160 feet here, so that wasn't a bad guess. Let's see if I can maybe redraw this a little more zoomed in and actually find the area. So remember, we had 3 walls, and here was the house. So we didn't really care about the fence there. And my guess was 100, and then 330 minus 2 times 100, 130. So then our area, 13,000 square feet?
That's definitely the highest so far, isn't it?
Ooh, what did you guys...
That's like almost double what we were getting.
So that's 13,000 square feet. And what did you guys get for the area of your of your just four-walled garden?
Mine
It
was
was-
6,500.
Was mine in the 7,000?
Yours was like in the was higher than mine. Yeah, it was
Yeah.
like 67 something.
I
Close
got
to 7,000?
13,000, so sorry guys, looks like I win for maximizing
But
area.
how do we know which one's the actual highest? Like, we just did 3 examples.
I don't know. Maybe we can get even higher than 13,000. This was just a guess.
Let's try to do this algebraically.
That's a good idea. Let's just do it once and for all in general and see if we can maximize this area.
Okay, so let's think about how I would label this rectangle with variables. So I'm going to draw the rectangle again here. And I'm just going to call one of the sides x.
So that would be like when we just chose a number.
Right, so I'm just going to give this side a variable and I'm just going to call it x. I have 330 total feet that I'm allowed to use, right?
Right.
And I've already used 2 x's of that.
But then we have to split that amount between these 2 remaining sides.
Right, because in the rectangle, the opposite sides are congruent. So that means that the other 2 sides, I can simplify that, can't I? So
Right.
330 divided by 2.
That's 165.
Yep, and then 2x divided by 2 is x. So this side is 165 minus x, and so is this side. If I were to write an equation for the area is just length times width. So the area of this rectangle could be modeled by the equation x times 165 minus x. And
Now, we don't know what the area is.
if I want to find the maximum area, that's what I'm trying to do, right? I'm trying to maximize this.
So how do we find the maximum area?
This is a quadratic,
Oh, yeah.
right? So, and it looks to me like if I were to distribute this x, that quadratic's probably going to be something that opens down.
Right.
I'll use my calculator.
Okay.
So if I type it into my calculator,
Can you type it in the way it is right now?
yeah. So I'll type it into my calculator and I'll set up a nice window so that I can see what it looks like. And it's definitely a quadratic. It's a quadratic that opens down. So according to what I have on the screen, I can find the maximum, the absolute maximum of this parabola on my calculator. And it looks like the maximum is at 82.5, comma 6806.25. Now, according to the way that I wrote it, this is what I would want my x to be to maximize my area, and this would be my maximum area.
So it's not that that's the length and that's the width.
No, right, exactly. So this 82.5 is really what I would need this x value to be to get my maximum area, and what I would need this one to be as well. And then, of course, if I have those 2 x's, I can get these 2.
So I'll just type that in the calculator. Oh, interesting.
So it looks to me like I just got a square.
Yeah. So do you think that will always work?
Yeah, I would think it would always work since I just did it out algebraically.
So if I want to maximize the area of a rectangle, I would make it a square.
Sounds good to me.
Okay. Let me try the other example.
Okay.
Okay, so Miss Marcus had this brilliant idea, she normally does, right? To use the house as one of the sides and then use the fence for just 3 of the walls. And what did she called these 2 sides 100 and 100, I think. Why don't we just call those x and x?
Okay.
So I'm going to follow what you were doing before. We had 330 feet, but we're using up 2x. But we're only using it on this side, so this side is really just the 330 minus 2x. We don't have to do that dividing by 2.
Right,
Because we're not dividing it by 2. Okay, so now we found the area of that rectangle. Okay, so the area of this rectangle would be x times 330 minus 2x. And you used your calculator. But,
Yeah, I graphed it on my calculator.
But, like, a lot of times we don't like using the calculator, or sometimes we just don't have it to use. So you were really finding the vertex, weren't you?
I was, yep.
Okay. So if I wanted to find the vertex either vertex form is really useful for that, or if it's not in vertex form, we could put it in standard form. I think it's actually pretty easy to go into standard form right
Yeah,
now.
let's do that.
So if I distribute this x, I get 330x minus 2x squared. Okay, I'll just rewrite that. Might be a little easier to see it as negative 2x squared plus 330x.
And now you definitely know that parabola's opening down.
Oh, right, okay. So I like to use the axis of symmetry formula, if you will. What is it, negative v over 2a?
Yeah.
Okay, so the axis of symmetry, let me write that down, the axis of symmetry would be at x equals negative 330 over 2 times negative 2. Okay, so negative 330 divided by negative 4 would be what?
82.5.
Isn't that what you just got on the last one?
It is what I just got.
That's weird. Okay. So if I were to graph this parabola, its axis of symmetry would be at 82.5, and its vertex, oh, I have to plug in 82.5 for x to find out what the area is. I could do that.
You could do that.
I could do it.
Or you could just figure out what that other side is with your 82.5 and then multiply them.
Oh, okay. So smart. Let's do that.
Okay.
So this side would be 82.5. 2 times 82.5 is what, like 165?
165, yeah,
Okay, so 330 minus 165.
is 165.
165, okay. Whoops. So those are my sides. I don't even need to really find the vertex necessarily,
Right,
because now those two sides will multiply to the area.
exactly. They're going to multiply to your maximum area.
Okay, so my area is really 82 times 165.
Which gives you 13,612.5.
And we're in feet squared. Is that the biggest one so far?
That's the biggest one so far.
Awesome. So I think that's really interesting that we could do it with either 3 walls or 4 walls. But actually now, Miss Marcus has really got me thinking, we could have even used the deck. Couldn't we have used that deck, like in that corner, in the nook area?
Oh, that's right, that
Yeah.
little, yes, that's right, that black rectangle there.
So lots of different options here. Something else I was wondering though, would these actually fit in my yard?
That is a great
Yeah.
question.
So would your answer fit in my yard? What was yours, 82.5 by 82.5?
Yeah, mine's definitely going to fit.
Okay, so 82.5, oops, let me just change color here. 82.5 by 82.5, that definitely fits this direction, right? We have 150 this way, and we definitely have enough space this way.
Perfect.
Okay. What about the 3 wall?
Well, no.
Those were different sides. So let's just ignore this is the old one here. If I'm using this part of the house, so if I have, what is it, one side,
165.
Oh, I can't even put it here.
No, you can't.
Okay. And I can't put it this way.
No, you can't.
So this was not going to fit.
It's not going to fit.
So does that mean that the one with the highest area was the 82.5 by the 82.5? I don't know.
But, I mean, is there a way to still use the side of the house,
That's,
But
yeah,
get- but get
I
a-
feel
but-
like we should be using it.
but get a bigger area than my square?
Like, what if we just used the 160?
Right.
I say we leave this to some of our students to figure out.
I agree.
Does that sound good?
Sounds great.
Awesome.
Good luck, guys.
Thanks for your help.
Thank you.